Some natural phenomenon. Charging by rubbing. A plastic comb, when rubbed on hair, attracts small pieces of paper and dry leaves. This is because on rubbing with hair, the plastic comb gets charged. A rubber balloon, when rubbed with wool, sticks to the wall. This is because on rubbing with wool, the balloon gets charged. When it is brought closer to a wall, it induces an equal and opposite charge on the wall, and hence it sticks. When materials behave in this way, they are said to be electrified or to have some electric charge. Transfer of charge. This scientific instrument is known as an electroscope. It consists of a metal rod with a metal ball and two aluminum foils at its base in a glass enclosure. This is used to detect charge. Sparks in the sky. Lightning. Lightning is the spectacular bluish-white light produced in the clouds. Everything but the thunder is usually over in less than half a second. During the development of a thunderstorm, there is an upward and downward movement of air currents. The vigorous movements of water droplets in the clouds cause separation of charges. The cloud acquires regions of different charge, with the bottom of the cloud generally negatively charged. As a result, an opposite charge is induced on the surface of the earth. The production of a lightning bolt begins when the negative charge at the bottom of the cloud gets large enough to overcome air's resistance to the flow of electricity, and electrons begin flowing towards Earth along a zigzag forked path at about 60 miles per second. As the electrons flow downward, they collide with air molecules and ionize them, producing more free electrons. Meanwhile, as the electrons approach the ground is becoming more and more positively charged due to the repulsion of electrons in the ground. This positively charged region moves up through any conducting objects on the ground, houses, trees, and people, into the air. When the downward moving electrons meet the upward flowing electron regions at an altitude of 100 meters or so, they form a complete circuit and the lightning begins. Because of the intense heat produced during lightning, the air suddenly expands and sends out huge pressure waves. These waves produce what we call thunder. This process of electric discharge can occur between two clouds, between clouds and the earth, even between clouds and the human body. A lightning strike could be fatal to living beings. Safety measures against lightning. Some safety tips. When you see lightning or hear thunder of a storm, rush indoors to protect yourself. If no shelter is available, get into a hard-topped vehicle with windows closed. Keep distance from vulnerable locations like isolated trees or isolated tall structures. Do not use wired phones. Mobile phones are the safest to use. Carrying an umbrella during a thunderstorm is not safe. Lightning conductor. It is a device used to protect a building from damage by thunder and lightning during a thunderstorm. Description. A tall building is protected by a lightning conductor, which consists of a thick copper strip on the outside of the building, which connects metal spikes at the top to a metal plate in the ground. A metal plate, usually copper, is buried deep in wet soil to ensure good conductivity between the plate and the earth. Working. Thunderclouds carry charges. A negatively charged one passing overhead repels electrons from the spikes to the earth. The points of the spikes are left with a large positive charge which removes electrons from nearby air molecules, so charging them positively and causing them to be repelled from the spike. This effect, called action at points, results in an electric wind of positive air molecules streaming upwards to cancel some of the charge of the cloud. If a flash occurs, it is now less violent and the conductor gives it an easy path to ground. Natural phenomenon. Thunder and cyclone are predictable natural phenomenon and safety measures can be taken against them. However, earthquake is one natural phenomenon which is unpredictable till date. It can cause considerable damage to human life and property. Earthquake. An earthquake is a phenomenon in which the ground suddenly and violently shakes and trembles. A mild earthquake lasts only a few seconds and is usually unnoticeable. The major or strong ones last a few minutes and leave behind them a trail of destruction. An earthquake occurring under the ocean causes a tsunami. It can also create landslides and floods. Causes of earthquakes. The earth consists of three distinct layers: the crust, the mantle, the core. The crust. It is the outermost layer of the earth with a non-uniform thickness of 6 kilometers to 40 kilometers. The mantle. It extends to a depth of 2,800 kilometers below the crust. The central region between the core and the crust is called mantle. As the depth increases, the pressure inside the mantle increases. The core. It is the innermost part of the earth and extends to a depth of around 3,500 kilometers. The tectonic plates. The crust of the earth is throughout not in one layer. In fact, it consists of many layers, one above the other. The layers are fragmented. Each fragment is called a tectonic plate. Earthquake happens along the edge of the tectonic plates. The plates move and push against each other. Sometimes these plates snap at the weakest point along a fault line. Big shock waves go from the focus where the shock wave starts. Earthquake terminology. Epicenter. It is the point on the surface of the earth vertically above the place of origin, hypocenter of an earthquake. This point is expressed by its geographical latitude and longitude. Richter scale. Magnitude is measured on the basis of ground motion recorded by an instrument and applying standard correction for the epicenter distance from recording station. Seismograph. Earthquakes generate seismic waves which can be detected with a sensitive instrument called a seismograph. Protection and precaution against earthquakes. Here are some precautions to protect your property. Check to see if your house is bolted to its foundation. Homes bolted to their foundations are less likely to be severely damaged during earthquakes. Repair any deep cracks in ceilings or foundations. Install strong latches or bolts on cabinets. Latches will prevent cabinets from flying open and contents from falling out. Hang heavy items such as pictures and mirrors away from beds, couches, or anywhere people sit. Bolt down any gas appliances. After an earthquake, broken gas lines frequently create fire hazards. Your personal safety. If you are indoors during an earthquake, drop, cover, and hold on. Get under a desk, table, or bench. Wait in your safe place until the shaking stops. Move carefully and watch out for things that have fallen or broken, creating hazards. Beyond the outlook for fires, fire is the most common earthquake-related hazard.